Ever pondered on this? How did the universe spring into existence from nothing? This question, in all its profundity, has intrigued minds for centuries, unfurling a maze of complexities. Stay with us as we journey through the theories that attempt to answer this enigma. To begin with, we must understand what we mean by nothing. In everyday language, nothing implies an absolute void, a complete absence. But in the realm of quantum physics, nothing takes on a rather different meaning. Here, nothing is a seething, bubbling cauldron of potentiality, where particles and their antiparticles are constantly popping in and out of existence. This is the world of quantum fluctuations. So what are quantum fluctuations? Well, they're random, unpredictable changes in energy at the smallest scales of the universe. These fluctuations are a direct consequence of the Heisenberg uncertainty principle, a cornerstone of quantum mechanics, which states that we cannot know both the position and momentum of a particle with absolute certainty. In this realm of uncertainty, energy can briefly convert into particles and antiparticles, which then annihilate each other and return to energy. Now you might be wondering how these quantum fluctuations relate to the origin of our universe. Here's where it gets interesting. Some cosmologists propose that our universe began as a quantum fluctuation in a pre-existing quantum field. Picture this, a tiny blip of energy popping into existence, inflating at an incredible rate due to the energy of the fluctuation itself. This inflationary period, followed by a slower, more steady expansion, could have given rise to the universe as we know it. In this scenario, nothing, this quantum field, gave birth to everything. The galaxies, stars, planets, and life forms that populate our universe. It's a theory that bridges the gap between the incredibly small world of quantum mechanics and the vast cosmic scale of astrophysics. But here's the thrilling part. If our universe could emerge from a quantum fluctuation, who's to say that other universes couldn't do the same? This idea leads us to the exciting and mind-bending concept of a multiverse where countless universes, each with its own laws of physics, could coexist. Quite intriguing, isn't it? But that's just the start. Let's delve deeper. The Big Bang Theory, you've probably heard of it. But what does it really entail? At its core, the Big Bang Theory is the cosmological model explaining how our universe expanded from a high-density and high-temperature state, often described as a singularity. But let's break it down further. Imagine the universe as a balloon. As you inflate it, every point on the balloon's surface moves away from every other point. This is akin to how galaxies are moving away from each other, suggesting that the universe is expanding. But if the universe is expanding, that implies it was once compact. If we trace the universe's expansion back in time, around 13.8 billion years ago, we reach a point where everything was incredibly dense and hot. This is the point of the Big Bang. A moment of creation, not in space, but of space itself. Now, you might be wondering, how does this support the idea of the universe coming from nothing? Well, it's a bit of a misnomer. You see, the Big Bang wasn't an explosion in the conventional sense, but rather an expansion of space-time. This expansion created matter and energy, which we perceive as the universe. In essence, the Big Bang Theory posits that the universe started as a singularity, a point of infinite density and temperature. This singularity wasn't located in space because there was no space before the Big Bang, it was space. And from this point, space began to expand, and it continues to do so even today. Now let's delve into quantum mechanics. Some scientists speculate that the singularity was formed due to quantum fluctuations, tiny ripples in the fabric of space-time. These fluctuations can create particles and antiparticles which annihilate each other, leaving behind energy. In the high-energy environment of the early universe, these energy fluctuations could have triggered the Big Bang, creating a universe from nothing. So the universe might have started with a Big Bang, but what's beyond our universe? Ever thought our universe could be just one amongst an infinite number of universes? Let's venture into the captivating world of the Multiverse Hypothesis. This concept, as mind-bending as it may seem, posits that our universe, with its unique set of physical laws and constants, is merely one bubble in an infinite cosmic ocean of universes, each with their own distinct laws and constants. Yes, you heard it right. There could be an infinite number of universes out there, each one unique, just like snowflakes in a snowstorm. So, how does the Multiverse Hypothesis tie into our quest to understand the universe's origin? Well, it provides a potential answer to why our universe appears to be so finely tuned for life. If there exist an infinite number of universes, each with its own unique set of laws and constants, then it's not surprising that we find ourselves in one where conditions are just right for life to exist. It's a bit like winning the cosmic lottery, except in this case there are an infinite number of tickets and we happen to be holding the winning one. But wait, there's more. The multiverse hypothesis also offers a potential explanation for the Big Bang itself. In some versions of the hypothesis, Big Bangs are happening all the time, as new universes bubble up and inflate from the quantum foam of the multiverse. Our universe's Big Bang could be just one of these countless cosmic births. However, it's important to note that the multiverse hypothesis, while fascinating, remains just that, a hypothesis. It's yet to be proven or disproven. The idea of multiple universes is a bold one, and it's one that scientists are still grappling with. It's a concept that pushes the boundaries of our understanding, forcing us to question our place in the grand scheme of things. While the multiverse hypothesis opens up a new realm of possibilities, how do scientists approach the question of creation ex nihilo? Stay tuned as we delve deeper into this profound question in our next segment. The question of creation ex nihilo has puzzled philosophers and scientists alike. In the realm of science, the concept of creation ex nihilo, or something from nothing, is approached with a blend of theories, hypotheses, and empirical evidence. The Big Bang theory, for instance, posits that the universe began from a singularity, a point of infinite density and heat. Yet this singularity wasn't something in the traditional sense. It existed outside of time and space as we understand them, thus it's often referred to as nothing, albeit a very potent form of nothing. Quantum fluctuations, another scientific approach, suggests that even in a vacuum, particles and antiparticles spring into existence and annihilate each other. These fluctuations could potentially give rise to entire universes, again creating something from nothing. But this nothing is not absolute nothingness. It's a quantum void, seething with potential existence. In contrast, philosophers have grappled with the concept of creation ex nihilo from a different angle. Many argue that nothing is an inconceivable concept, as even our imagining it becomes something. Some propose that existence is a fundamental aspect of reality and that nothingness is merely a human abstraction. Others draw upon metaphysical arguments, postulating an uncaused cause or a necessary being as the origin of all that exists. Comparing these perspectives, we find a fascinating interplay of ideas. Science, with its empirical focus, seeks to explain creation ex nihilo within the framework of physical laws and observable phenomena. Philosophy, on the other hand, delves into the metaphysical, exploring concepts beyond the physical realm. Yet both disciplines grapple with the same fundamental question: how can something come from nothing? Interestingly, the boundaries between these perspectives are not clear-cut. Some scientific theories, like the multiverse hypothesis, venture into the realm of the metaphysical, while some philosophical arguments incorporate scientific findings. This interplay reveals a shared quest for understanding, a shared pursuit of answers to some of the most profound questions of our existence. As we can see, the origin of the universe from nothing is a complex and intriguing question. From quantum fluctuations to the Big Bang to multiverse hypotheses, the universe's origin theories are as vast as the universe itself. In our cosmic journey today, we've taken a deep dive into the abyss of the unknown, uncovering the fascinating theories on the origin of the universe. We started with the idea of quantum fluctuations, the intriguing concept that the universe may have been born from a random, minute disturbance in the vacuum of space-time. This theory, though abstract, has been fueled by significant advancements in quantum mechanics. Next, we explored the Big Bang, the theory that has gained the most acceptance over time. It suggests that the universe expanded from an extremely dense and hot state and continues to do so even today. The evidence supporting this theory, like cosmic microwave background radiation, has been compelling. We then ventured into the realm of the multiverse, a hypothesis that posits an infinite number of universes, including the one we inhabit. This idea, while mind-bending, opens up a plethora of possibilities and questions about the nature of reality. Lastly, we examined the philosophical and scientific perspectives on creation ex nihilo, the concept of creation out of nothing. This age-old question has been a subject of debate among philosophers, theologians, and scientists for centuries, and it continues to be a rich field of exploration and research. The quest for understanding the origin of our universe is an ongoing journey. With each passing day, we inch closer to the answers, revealing more about the mysteries of existence. This journey, while daunting, is an exciting testament to human curiosity and our relentless pursuit of knowledge. The quest to understand our universe's origin from nothing continues, inviting us all to ponder on the mysteries of existence. Until next time, keep exploring. Keep